Welcome to this video all about probability tree diagrams. You can find the PDFs of the exam questions and the solutions on mathsupgrade.co.uk. The first few questions are all non-calculated questions. The first question states that Amina has got 2 bags. In the first bag she's got 3 red balls and 7 green balls. In the second bag she's got 5 red balls and 4 green ones. She takes at random a ball from the first bag and then takes at random a ball from the second bag. Complete the tree diagram, and that's 2 marks. So you can see some of the fractions are already completed here on the tree diagrams. We need to complete the other fractions. So the first thing you can just say is that since there's either red or green in the first bag, this fraction here must add up with this fraction to give one whole one, since they're mutually exclusive events. So this fraction here must be 7/10. But also you can tell that from the question here as well. It says that in the first bag there's 7 green balls and there must be 10 altogether, so this fraction must be 7/10. And we can answer the other branches in the same way really. So in the second bag we know there's 5 red, so there must be 4/9 since these two must add up to one whole one. And it tells you that in the question as well. There's 4 green balls out of 9 altogether in the second bag. Since the second bag's probabilities are not affected by the first bag's probabilities, these 2 fractions here must be the same as these 2. Since it doesn't matter what you pick from the first bag, that doesn't affect the second bag. So there's the 2 marks there. Part B states we need to work out the probability of taking 2 red balls. So in this question here, you need to just follow the path of red and then red again. So if she takes 2 red balls, that'll be a red ball, so that's 3/10, and another red ball, that's 5/9. So you need to multiply these 2 fractions together, since the probability of one and the probability of another is given by the product of the 2 probabilities. So it's a multiply. So when you multiply them, you can just multiply the numerators together, which gives you 15, and multiply the denominators together, which gives you 90. You can then cancel that to write it in the simplest form, which is 1/6, and that's the 4 marks for that question. Question 2 states that Ria takes 2 counters from the bag, which has got green and blue counters in. We got to find the probability she takes 1 counter of each colour, so either green and then blue, or blue and then green. The tree diagram is going to look like this, since from the first choice you've got green or blue, and the second choice you've still got green or blue. The fractions for green in the first choice is going to be 7/9, since 7 are green and there's 9 altogether. So blue must be 2/9. Then in the second choice, if you pick green, you can have 1 less green, so that's 6 greens out of 8 counters. And blue is still going to be 2 blues out of 8 counters altogether. In these fractions here, if you pick a blue one, then you're still going to have 7 green ones, but out of 8 altogether. And if you pick a blue one, you can have 1 less blue one, so that's 1 blue out of 8 altogether. The probability she takes 1 out of each counter is given by the product of this pathway, so green then blue, or this pathway, blue then green. So it's green and blue, so that's 7/9 times 2/8, which is 14/72. And this pathway is 2/9 times 7/8, which is again 14/72. The probability is going to be this pathway or this pathway. So it's a sum of these, since this or this gives us our outcome. That's going to be 14/72, add 14/72, which is 7/36 when it's simplified. And that there is 4 marks. Question 3 is worth 4 marks, and we're told that Graham has got a fair red 6-sided dice and a fair blue 8-sided dice. He's going to roll both dice. To complete the tree diagram first of all for 2 marks. So the first section of the tree diagram is for red dice. So if you look at the number the red dice can land on, it can land on 1, 2, 3, 4, 5 or 6. So probability of landing on a 6, well there's 1 6 out of 6 altogether, so that's going to be 1/6. And so this must be 5/6, since both of these branches must add up to one whole one. Similarly with blue dice, There's 8 numbers altogether. It's a fair dice. The probability of landing on 6, there's 1 6 out of 8. This must be 7/8. And similarly for these fractions here. So there's your answers there for the 2 marks. In part B, we need to work out the probability that neither dice will land on a 6. So neither dice landing on a 6 is this branch here and this branch here. Since it's an and, it means multiply. And is multiplying probability. So I need to do 5 6 multiplied by 7/8, and that becomes 35/48. And that's the 4 marks there for that question. The remainder of the questions are all calculator questions. We need to work out in question 4 the probability that Finley wins both matches for 2 marks. So probability of winning the first match is 0.7, probability of winning the second match is 0.7, so probability of winning both is this probability multiplied by that probability. So winning and winning, and that is 0.49. Part B, we need to work out probability that Finley loses at least 1 match. Losing at least 1 match means he could lose both, or he could lose the first one and win the second one, or he could win the first one and lose the second one. Now you can do this question by doing 0.7 times 0.3 to give this outcome, 0.3 times 0.7 to give this outcome, and 0.3 times 0.3 to give this outcome, and then you could add those 3 outcomes together. But since we've already worked out this top outcome here, probability of winning both, and since all 4 outcomes are mutually exclusive and they add up to 1 whole one, you can just do 1 whole one, subtract this probability here. So if we do 1 whole one, subtract 0.49, that'll be the answer, and that's 0.51, 4 marks. In question 5, we're given a fair 4-sided spinner. Hasmi is going to spin the spinner twice. We need to complete the probability tree diagram. So, since the spinner's got 4 sides, and 3 of them have got A on it, then this probability here is going to be 3/4, and this probability here must be 1/4, since I must add up to 1 whole one. Since his second spin isn't affected by his first spin, these probabilities are going to be exactly the same as the first branch there. So that's the answer there for part A. In part B, the question asks us to find the probability that the spinner will land on A on the first spin and B on the second spin. So here's the pathway here. Here's the first spin landing on A, and here's the second spin landing on B. So it's 3/4 and 1/4. So it's 3/4 multiplied by 1/4, which is 3/16 as a fraction. The whole question there was worth 4 marks. Question 6 is a reasoning question. We need to give reasons as to why the tree diagram isn't correct. So the probability of landing on 4 is 0.65. So that looks fine here, but clearly this probability, add this probability, doesn't give 1 whole one. So that number's wrong there. Similarly, these 2 numbers are both wrong, since they're the wrong way around. So that's what we'd write for our reasoning here. So I've marked on the tree diagram the numbers which are incorrect. The whole question there is worth 2 marks. Question 7 is worth 2 marks. We need to find the probability of winning both games given this tree diagram here. So the probability of winning both games is given by this pathway here. So it would be 0.2 times 0.3, and that gives 0.06 with the calculator. That question is worth 2 marks. In question 8, we need to find the probability that Bisma will be late on exactly one of the 2 days. So that means not late on both days, just late on one of the days. So that's going to be either this pathway here, so late on Monday, not late Tuesday, or this pathway here, not late Monday, but late on Tuesday. Okay, so it's this pathway here, which is 0.07 times 0.98, or 0.93 times 0.11. So I've worked out these 2 probabilities here. I didn't need to work out these 2 really. So now I just need to add those up, since OR is add in probability. So this is going to be 0.0686 add 0.1023, which gives us 0.1709 for 3 marks. In question 9, I need to complete the tree diagram. I'm told that the probability should be late on any one day is 0.15. So I can simply put 0.15 in that space there, and 0.15 in that space there, and the remaining spaces must all be 1 subtract 0.15, which must be 0.85. So 0.85 there, and there, and there. So that's what the tree diagram will look like. In part B, I need to find the probability that a train will be late on at least one of the 2 days. I can find all of these pathways probabilities here. So I can find 0.15 times 0.15, 0.15 times 0.85, and similarly for these ones here. But a quick way of doing it is just realizing the probability that she'll be late on one of the 2 days is 1 minus probability that she won't be late at all, so that she'll be on time. Now here's a probability that she'll be on time on both days, 0.85 times 0.85. So if I just do 1 subtract that, that'll give me the answer in the quickest way possible, and that's 0.2775. So that was 5 marks for that question. In question 10, I'm told that Samina has a round pencil case and a square pencil case. There's 4 blue pens and 3 red pens in the round pencil case, and there's 3 blue pens and 5 red pens in the square pencil case. She takes at random a pen from each pencil case. You need to complete the tree diagram. So what I need to do here, I need to put the information into this tree diagram here. I'm told that there's 4 blue pens and 3 red pens in the round pencil case, so that's going to be 4 out of 7 here, and this must be 3 out of 7. And in the other pencil case, which has got nothing to do with this one, I'm told that there's 3 blue pens and 5 red ones, so this must be 3 eighths and 5 eighths and 3 eighths and 5 eighths. So there's the tree diagram there. In part B, I need to find the probability that the pens Samina takes are both red. So probability of the first one being red is 3/7. Probability of the second one being red is 5 eighths. So probability of red and red is 3/7 times 5 eighths, which becomes 15 over 56 for 2 marks. Question 11 involves relative frequency. If you're not sure on relative frequency, be sure to check out my video file on this channel. Alan's got 2 spinners, spinner A and B. They can land on either red or white. Probability of spinner A landing on red is 0.25 as shown here, so this must be 0.75. Probability that spinner B lands on red is 0.6, so this is 0.4. I need to find the number of times, an estimate for the number of times both spinners land on white, given that the number of times that both land on red is 24. So in this question, we don't know how many times he spins both of them, okay? But we can estimate, since we know the number of times both spinners land on 24. So the way to do that is first of all find the probability of red and red, which is 0.25 times 0.6, which is 0.15. Now I'm going to find the probability of white and white, which is 0.75 times 0.4, which is 0.3. Now since I know that the probability of red is 0.15 and another number of times it lands on red is 24, I'm going to equate those to each other. Using proportion, I know that the probability of landing on white was double the probability of landing on red, because 0.3 is double 0.15. So the number of times it lands on white must be double the number of times it lands on red. So you'd expect it to land on white 48 times as an estimate. It's only ever an estimate since nothing's really guaranteed. So it's a theoretical probability. And that question there was 3 marks. In question 12, the first part of the reasoning question, I'm given the tree diagrams there, and I need to write down one thing that's wrong with the probabilities in the tree diagram. Well, first of all, if you choose 2 students at random from the class, once you've chosen 1 student, there'll only be 29 students to pick from. That's the first thing. So that's for 1 mark there. And I've marked it on the tree diagram as well. Otherwise, the tree diagram looks okay. In part B, I'm giving some more information. I'm told that Owen and Wassim play for the school football team. The probability that Owen will score a goal is 0.4. Probability Wassim will score a goal is 0.25. Another reasoning question. We're told that the probability that both boys will score a goal in the next match is 0.4, add 0.25. Is that correct? Give reasons for your answer for another mark. So he's wrong, since he's actually added up these probabilities, right? So he's found the probability of Owen or Wassim scoring, right? What he should have done is should have multiplied. If he multiplies, then that gives the probability of Owen and Wassim scoring, which is 0.4 times 0.25, which would be 0.1. That question there was 1 mark. In the last question here, we're given 2 sets of traffic lights. We're told the probability of being stopped by the first set of lights is 0.4. So straight away you can put 0.4 on this branch here. So this must be 0.6, since they add up to one whole one. If he's stopped by lights A, the probability of not being stopped by lights B is 0.7. So you can put 0.7 on this branch here, so this must be 0.3. And if it's not stopped by lights A, the probability of not being stopped by lights B is 0.2. So this must be 0.2 here, this must be 0.8. So they're the probabilities on the branches. In part B, we're told that Mark drove along the road and is stopped by just one of the sets of traffic lights. Is it more likely he's stopped by A or B? We must show you working. So the key thing here is he's stopped by just one of the sets of traffic lights. So that means he could either have gone along this pathway here, so stopped by lights A, not stopped by lights B, or this pathway here, not stopped by A and stopped by B. So you need to compare those two probabilities. So you need to do 0.4 times 0.7, which is 0.28, and we need to do 0.6 times 0.8, which is 0.48. So which of those are more likely? This one is greater, so it's more likely to stop by lights B. That's 5 marks for the whole question. Be sure to check out my other videos on this channel. Thanks for watching.